This is a video lesson for our day 2 of our decimals unit, and our learning target for today's lesson is I can use metric measurement and area models to represent tenths as fractions greater than 1 and decimal numbers. So we're going to be taking a look at two new ways that we can represent decimals or decimal numbers, and that's using metric measurement and area models. So let's get started by taking a look at how we can represent tenths with metric measurement. So down below here I have a ruler that is representing centimeters, and if you look at the gap between 0 and 1 centimeter, we have these little tick marks right here. And each of these little tick marks, if you were to count them up, there's actually 10 of them between 0 and 1 centimeters. That means that each of these little points is worth 1/10 of a centimeter. So knowing that, we're able to represent decimal numbers larger than 1 with a metric measurement. So let me show you how that would work. So let's say, for example, I wanted to draw a line segment that was 2 6/10 centimeters long. What I would do is I would start at 0 and I would first draw the line segment that represents the whole number, 2 centimeters. So I'm going to do that first. Then after that, I would add on 6/10 or 6 tick marks past. So I go 1, 2, 3, 4, 5, 6. So that's going to lead me to right here. So I'd continue my line segment until I got to that point. So if I isolate my line segment here, let me just go ahead and do that now. I've created this line segment right here that from this end to this end equals 2 6/10 centimeters, or 2.6 centimeters if I'm writing it as a decimal. So let's take a look at one more example here of representing a decimal with a metric measurement. I'm going to move my ruler down a little bit. I'll go ahead and erase these little lines here, and I'm going to represent, let's see, I'm going to represent 3 8/10 using metric measurement. So let's move my ruler. And so the first step is going to be to represent 3 centimeters on my line segment. So I go to 1 full centimeter, 2 full centimeters, and then 3. And then count up to 8/10. So I count my tick marks, my tenths, 1, 2, 3, 4, 5, 6, 7, 8/10. So I'm going to get to right here. And then I've created this line segment right here that is equal to 3 8/10 centimeters, which of course if we represent that as a decimal would be 3.8 centimeters. So these two are the same. So we read this as 3 8/10 centimeters. So that's how we can represent tenths with metric measurement, by creating line segments that are equal to mixed numbers or decimals that are larger than 1. Another strategy we can use to represent tenths is with an area model. So this strategy should look somewhat familiar. Our area model does look a little bit different though. We have a square, and if you count the partitions here, it's split into 10 equal parts. So each one of these lines is equal to 1/10. So when we're using this area model, we're saying that this whole area model is equal to 1 whole. And each of these little lines is equal to 1/10. So if we wanted to represent, let's say 0.7 or 7/10 on the area model, we would fill in 7 of the tenths, and we have represented 7/10 or 0.7 as a decimal on our area model. So the cool thing about the area model is we can actually represent numbers that are larger than 1. So in this case, I'm going to show you how you would represent 2 3/10 using an area model. So in order to do this, I need to represent 2 wholes using the area model. So I'm going to actually fill in 2 whole squares. So there's 1 hole filled in, and there's 2 holes. So I've just represented 1 hole and then 2 holes. So that gives me 2 holes total, and then I'm going to represent 3/10. So I'm going to fill in 3 of the 10 equal parts on the second one. So this little section is equal to 3/10. So what I've done is I've essentially made 2.3 or 2 3/10. I've represented that with my area model because I have 2 holes filled in, one right here and one right here, and then my 3/10 is represented in this area model right here. So let's take a look at one more example, this time representing a large decimal with an area model. So I'm going to be representing 3 9/10 with an area model. So I start with the whole number. I know that each one of these area models here, or each one of these squares, is equal to 1 whole. So I need to fill in 3 of them. I'm going to go ahead and do that now. So here's the first one. Oh, missed a couple. So there's 1 whole. There's 2 holes. And there's 3 holes. And so next I need to represent the 9/10 in the area model as well. So for this last hole, I'm only going to be shading in 9 of the equal parts. So I'm going to go ahead and do that. So I still have one that's unshaded. And that shows me that I have 3 holes plus the 9/10, or 3 holes plus 9/10 written as a decimal, and this equals 3 9/10, or the decimal 3.9. So there you have it, 2 more strategies we can use to represent decimals and large mixed numbers using metric measurement and the area model. So you should be ready to handle all the problems in the day 2 problem set. And if you have any questions or get stuck, you can come back and rewatch any parts of the video to refresh yourself on these new strategies. So thanks for watching and good luck.